Hey everyone, so today I'm going to give you a demo of the ICAL Human in the Loop interface that we've developed so you can try it out yourself and teach an agent a new task on the web. So we have our GUI running here, we've started it up, and you can go to the ICAL repo in the Visual Web Arena section to see how to run the GUI. So here we are on the GUI site, and it's just a local site that will pop up. And so this is the interface, and we have the starting URL that the agent will start at, the instruction that we want to teach our agent this particular task. So we're going to start on IKEA, and the task that we're going to try to teach the agent is buy me a lamp under $100. And we're going to enable feedback so we can give the agent feedback as it's failing. And we have some options here. We have our fine-tuned model from the paper, and we also have GPT-4o. We're going to start with GPT-4o, just the base ICAL model. So this base ICAL model has never been to IKEA. It doesn't fully know the layout of IKEA, so we're going to try to teach it this new task. So we can go ahead and click Start Agent here. And a Chromium instance will appear. And so this is going to be, it's starting at IKEA, and this is going to be the Chromium instance that the agent is going to be interacting with. So here on the GUI, we have several things. So the first thing is you're viewing what the agent is given in terms of the web page and the set of marks representation, where each of the numbers and bounding boxes here corresponds to an HTML element that the agent can interact with. So we give this in the prompt, and it can see this web page. You can also see here that we have a propose action. So this will query the model for an action. And then we have this commit action. So once we propose an action and we like the action, we can commit it in the environment. And then we have this feedback box where once we propose an action, we can give feedback back to the model, telling it to do something else or change its behavior in some way. So we're going to go ahead and propose an action. So the action that it's proposed here is to click the lighting element, element 37. So if we look at the web page here, this is this lighting element here. And so to buy a lamp under $100, this seems reasonable, but actually from navigating IKEA, I know that it's probably more efficient to just search in the search box. So we're going to go ahead and give some feedback here saying it's actually more efficient to just search in the search box on the home page rather than click on a category. So we can go ahead and apply this feedback. And so this is going to send the feedback back to the model and ask it to change its behavior. So here we have a revised action given the feedback, and now it's going to type lamp into element 6. So element 6 is the search box, so this looks good. And if we scroll down, we can also see the chain of thought or the programs of thought that ICAL outputs. So you can see it has some explanation of the action it's chosen. When we give it feedback, it also has these abstractions, abstracting out the feedback into some generalizable knowledge, the plan and summary, and then finally the action. So let's go ahead and commit this because I like this action. I think it's very efficient. So we're going to go ahead and commit this. So this is going to execute the action in the Chromium instance, and you can see now the agent has typed lamp into the search box, and we can see the new web page. So let's go ahead and propose a new action from the model to see what it wants to do next. So the next action it wants to click is element 28, price. So it wants to sort by price, and that's reasonable, but maybe let's just first have it scroll down to check the prices of the current lamps on the page. So just scroll down to check the lamps and prices. So let's apply this feedback. Okay, so now it's going to scroll down. Let's go ahead and commit that. And we scroll down, and now we can see there are plenty of lamps under $100. So hopefully it will just select one of them. Let's see what it does. Click 18. Okay, so it's identified this floor lamp, an $8 floor lamp. So it is under $100. It fits our criteria, and it's going to click element 18. So this is going to add it to the shopping bag, this button here. So that seems like a good action. Let's just go ahead and commit that. Okay, it's added to the bag. There's a little indicator at the top right showing that it's been added. Let's propose the next action. Okay, so it's now trying to click 18 again. And so this is a wrong action. It's already added the lamp to the cart. So it's getting a little bit confused here. So let's say you already added the lamp. Navigate to the shopping bag. Can apply that. So, okay, so now it's going to click show here, which will go to the shopping bag. So that's a good action. Let's commit that. Okay, now we're at the shopping bag. We can see the lamp has been added to the cart. And so everything looks good. Let's propose the next action. And it wants to continue to the checkout. Okay, so that's reasonable given our intent, but maybe as a user, I'm not super comfortable with the agent going all the way to the checkout and buying the lamp. So we can also give it some preferences. So we can say, I'd prefer that you stop at the shopping bag. So this is my preference. And now it has stopped here. So we can go ahead and commit this, and it's going to end the episode. And so now that it's ended the episode, it's saved out this trajectory. And it saved out the optimal trajectory along with the chain of thought. And so now we can either use it for retrieval augmented generation, RAG, with GPT-4o, or we can fine tune on this. So I'm going to show you an example of using this particular example with RAG. Okay, so now we're going to load up the trajectory into a RAG database and then use it to help the agent perform a similar task. So here we are in a cursor instance, and here is the ICAL repo, and we're going to go to this real-time agent runner, which has the agent code for this particular GUI. And this previous trajectory has been saved to the experiments folder. So everything that we were doing before has already been saved. So today's date. And here is the trajectory that we just recorded and gave feedback to for the particular objective of buy me a lamp under $100. So here we have a JSON file of all the information that the agent saw, along with the chain of thought and all this. So we can load this into a database. So we already have retrieval embeddings for different parts of this observation and task. And we have all the images from that trajectory. And so what we're going to do is we're going to load this up into a database, and we can do this fairly easily. I've already done it here in Real-Time Agent Runner. So if we go to Real-Time Agent Runner, and we want to go to the case where human feedback is enabled in the init section of Real-Time Agent Runner. So we can scroll down here, and if we just add to the change values here a new JSON, we can add this planning examples from our experiment section here to the instruction JSON, and we can append that to the list that we'll end up retrieving. So now when we load this up, it will read from this JSON for additional context. So now we can go back to our GUI, and I've already loaded up the GUI with the new changes. And let's go ahead and enable feedback again, just in case, but hopefully we won't need too much feedback since it's already learned from the previous example. So we can go ahead and start our agent here. And it's going to be the same task at the same user. You can also try slight variations to the task, and it should work just as well. But just for demo purposes, we'll do the same task. So let's see how much it's actually learned from the previous example. So let's go ahead and propose an action. And this time it's going to read the context from our previous example. So, okay, if you remember before, it tried to click on the lighting here, but now it's learned to type in the search box here. So we can go ahead and commit that. We don't need to give any feedback. Okay, so now we're at the search page. We can propose an action. And it wants to scroll down. So before it tried to sort, and now it's correctly trying to scroll down based on the previous example. So we can go ahead and commit that. And it scrolled down. So let's propose the next action. Okay, so it's going to click button 20 here, which corresponds to adding it to the shopping bag. So we can go ahead and commit that. And it's been added to the bag. Let's propose the next action. If you remember before, um, it tried to add the same item again to the shopping cart. Here, it's correctly going straight to the shopping bag after adding it. So it's correctly learned from the previous example not to continually add the same item. So we can go ahead and commit this. Now we're at the shopping bag. And before we want it to stop here rather than continue all the way to checkout. So let's see if it's learned this preference. Okay, so it's correctly decided to stop here at the shopping bag and not go all the way to the checkout. So you can commit this and it's completed the trajectory without any feedback. So if you remember before, we needed 3 or 4 feedback requests to the model to get it to successfully complete the task. Now we needed 0. So just in one example, we've been able to dramatically reduce the amount of feedback needed from the human. And let's actually quickly show you that this does some generalization. So let's try maybe buy me a frying pan under $100. So we can start up a new Chromium instance here with this new user intent. So it's going to load up the instance. And we can go ahead and propose an action once the observation has loaded. Okay, so we're at the home page here. Propose an action. Okay, so here instead of clicking a category, it's again typed. So even with alterations to the user intent, we can see that it's doing something similar to the example. Let's commit this. Okay, so it's search for the frying pan. Now let's propose the next action. Okay, it's going to scroll down, similar to the example. We can commit that. Let's propose a new action. It's going to add this frying pan, number 27, to the shopping bag. That seems good. Okay, it's added to the shopping bag. Propose the next action. It's going to go to the shopping bag. And now it's decided to stop here, which is good behavior based on what we told it before. So you can see we can generalize this to new examples, and use this human in the loop procedure to learn new tasks on the web.